So we're looking at Lesson 5, Part 2, and we just want a reminder of the rules that when we have the same base, and we have our same base here, x, what we do with the exponents is to add the exponents. When we're raising a power to a power, we multiply the exponents, and that we can share the product of a power. And so we have here we have x to the a and y to the a, so sharing that power with a product. When we have a quotient of powers, we subtract the exponents. And we can also share the power within a quotient. So we end up with, again, x to the a over y to the a. So that's a reminder of our exponent rules. So for exercise 11, we have our dividing the same base. So we know, because of our subtraction rule, that we can rewrite this as 19 to the 2 minus 5. But of course, 2 minus 5 gives us a negative 3 as the exponent. And now we know that we can write that as a fraction with a numerator of 1, and then we could put 19 in the denominator with a positive exponent. We're going to try that with exercise 12. Here we have now 17 to the 16 minus negative 3. And so that's 17 to the 19th. And that is just a positive power. For exercise 13, we have that sharing of the exponent of negative 4 being shared with the numerator and the denominator. And then we want to rewrite that. So when we have that negative exponent, we can put it in the reciprocal. So we can take that 7 to the negative 4 and put that in the denominator with a positive. And then the interesting thing here is we can take that denominator of 5 to the negative, and we can flip where that is and make it positive as well. So our negative exponent just kind of tells us to put it in the opposite place to make that exponent positive. All right, so let's take a look at some extra practice here. We have our same base of 3. And when we're multiplying the same base, we know we can add the exponent. So that for that first extra practice, we have 3 to the 3 plus 2 plus 1 plus 0 plus negative 1 plus negative 2. And we can go through that arithmetic, but we can also realize that here we have a 1 and a negative 1 that's going to cancel, and a 2 and a negative 2 that's going to cancel. Of course, when we add 0, that does not change anything. And so we really just end up with 3 to the 3rd, and we can leave that in exponential form. For our next one, again, we're looking at the same base. So we have 5 to the 2 plus 10 plus 8 plus 0 plus negative 10 plus negative 8. Can you look at that and see the same kind of canceling that we did before? We have 8 and negative 8 that will cancel. We have 10 and negative 10 that will cancel. Adding 0 doesn't change anything. What do you end up with? You end up with 5 squared. And then we look at the next one. It's the same idea, just looking at it in algebraic form. Our base is a, and we have that base to the m plus n plus l plus the negative n plus negative m plus a negative l plus 0. So we're going to try and cancel things out like we've been. We have m and negative m that will cancel, n and negative n that will cancel, L and a negative L that will cancel. So we really just end up with a to the 0. And what is anything to the 0 power? We have a to the 0 power. Anything to the 0 power is 1. All right, so just taking a look at some other practice here just to remind you of the rules and get some extra practice in here. So we have 6 to the negative 3 power. Again, that negative power means that we can write the base in the denominator with a positive power and put a 1 in the numerator. For example, B, just pointing out that we can do that with the 7. The same idea is that we put the 7 in the denominator with the positive power, so taking away that negative by putting it in the denominator, but that the 5 does not have a negative power, so that goes in the numerator. Now for exercise C, we get that negative, and negative is like the flip, and so we can put the 2 down here with a positive exponent. Then that means we can put the 8 in the numerator with its positive exponent. And then here, just practicing again, what do you think you would write this as with a negative exponent? Hopefully you've got 1 over 7 and then making that exponent of 2 positive.